This is part 2 of the homework video guide on differential equations. And for this video, we have a few more problems to solve, and we'll be dealing with exponential functions for part 2. So once again, when we're solving differential equations, our final answers should be written in the form of y equals to some equation. Okay, so if I take a look at my question here, I have y of 0 is 3. So if I just translate that into a point, that's really the point 0, 3. So the equation will pass through that point. And what I see here is in the actual problem, I have a plus y over here. So I'm going to move that to the other side to get the problem started. So I have dy over dx equals to 1 minus y. And then the next stage of the problem is you want to make sure that all the variables are on the same side of the equation. So I'm going to just interchange these two parts. So if I do that, I get dy all over 1 minus y equals to dx. And as you can see here, all the the y's are on one side of the equation and the x's on the other side of the equation. Okay, now on the left-hand side here, I'm going to rewrite this as 1 over 1 minus y times dy equals to dx. All right, so our goal is I want to isolate for this y, and I have to get rid of this dy somehow by taking the antiderivative. Now, in order to take the antiderivative, we just need our integral signs. All right, the integral signs will remove the dy's and the dx's, and now we got to find the antiderivative of both sides. Now, when I take a look at this expression right here, you can definitely use substitution, but the antiderivative of that is going to be ln. Anytime you have 1 over something, the antiderivative will start with ln, and it's the ln of 1 minus y. And I know that because there's a minus sign in the middle here, in front of the variable, I need to have a minus sign in front. Okay, so if you've done enough of these, you can probably eyeball it and figure that out. If not, you can always take the derivative of this expression, which is 1 over 1 minus y, and then what is the derivative of negative y using the chain rule? Well, that's going to be negative 1, and then this negative 1 over here tags along, and as you can see, the negative signs cancel out, and you actually get back to the original problem there. Okay, so if you can just look at the problem, you can figure out that the antiderivative is negative ln of 1 minus y, and you can check your answer by taking the antiderivative. Okay, so after you take the antiderivative of the left-hand side, take a look at the right-hand side. This is really the integral of 1 times dx. There's an invisible 1 there, and the antiderivative of 1 is going to be x and then plus c. Okay, so there's our antiderivative right there on both sides of the equation. So I have negative ln of 1 minus y equals to x plus c. After that, let's go ahead and solve for y here. So let's get rid of this minus sign. If I do that, I have ln of 1 minus y equals to negative x and then minus c. So that's how you get rid of that minus sign. After that, you want to get rid of the ln here. So if you want to get rid of the ln, you have to raise everything to the power of e. So if I raise the left-hand side by e, I need to raise the right-hand side by e as well. Okay, so the e and the ln, those kind of like wipe each other out. So now I have 1 minus y on the left-hand side equals to e to the power of negative x minus c. Now, for most of these questions for this homework video guide, you have to be able to simplify, this expression right here. And you might have to go back to some exponent rules from Math 9, where if I have a to the power of b times a to the power of c, if the bases are the same and if you're multiplying, you simply add the powers. So that's going to be a to the power of b plus c. So right now, if you take a look at your work here, a to the power of b plus c is kind of representing this expression right there. So now you can write it as two bases to the powers. So that will look like e to the power of negative x times e to the power of negative c. Okay, so on the right-hand side, you want to split it up so that you have two bases that are the same. These are my two bases that are the same. and you just want to have single exponents. And then on the left-hand side, I just have 1 minus y. Okay, so one of the reasons why we write the right-hand side into two different exponents with the same base is that you need to recognize that this part right here, this e to the power of negative c, e is like 2.7 something to the power of a negative constant. You have to recognize that this is just a constant. So we're going to use the letter a to represent a constant right there. And that's going to be e to the negative x times a, and then I have 1 minus y on the left-hand side. All right, so we split up the exponent so that we can write our constant like that with the letter a. After that, I would recommend just kind of rearranging the terms here. So unfortunately, most of these differential equation problems, there is quite a bit of algebra involved. So I would rewrite the right-hand side like that. After all that work, we need to go back to the original question here, and we need to use this initial condition right here, y of 0 equals to 3, where x is 0 and y is 3, to solve for our constant now. Okay, so let's go back to our last step here. We know that the equation goes through the point 0, 3. This is going to be x, and this is going to be y. Okay, so anytime I see an x, I'm going to replace the x with a 0, and anytime I see a y, I'm going to replace the y with a 3. Okay, so let's continue with that. This is going to be 1 minus 3 equals to a, and then e to the power of negative 0. And anything to the power of 0 is always going to be 1, so I just have an a on the right-hand side, and 1 minus 3 is going to be negative 2. So my a value is going to be negative 2. Okay, let's go back to some of the previous steps. So, and let me just erase all this now. And let me go ahead and box this step right here in red. I will continue the problem from this step right here. So I know that a is going to be negative 2. So if I continue writing out the problem, I have 1 minus y equals to negative 2 times e to the power of negative x. Okay, so from there, we just need to solve for y now, and I guess the best thing to do is it's probably best to just interchange this negative y and this negative 2 e to the negative x. So just interchange those two pieces. If I do that, I get 1 plus 1 plus 2e to the negative x equals to y. And that right there is my final answer for this particular problem. Okay, before I move on to the next question, we should also understand what this answer really means. So I can't do this for all the problems, but for this very first question, let's just verify that our answer actually does satisfy the conditions. Okay, let's go back to the original problem here. I think we had this step right here, so going way back. Let me just clear up some space here. Okay, so I know for a fact, after we did all our work, our answer was y equals to 1 plus 2 e to the negative x. That was our answer that we found. Okay, so if I take a look at my original problem here, let me just use a pink marker here. If I highlight the left-hand side in pink, that means I need to find the derivative such that the left-hand side will equal to the right-hand side. Okay, so I know that if this is my derivative right here, this is my solution, let's go ahead and take its derivative now, which is going to be y prime equals to 0 plus 2e to the negative x, and then using the chain rule, the derivative of negative x is going to be negative 1. So my derivative is going to be negative 2e to the negative x. Okay, I'm just multiplying the negative 1 with the 2 there to get negative 2. Okay, so what that means is my derivative is really, I can just move that over here. So once I have my answer, and if I take its derivative, that will represent the left-hand side of the original problem. Okay, let me just erase all that. And then on the right-hand side of the problem, I still have 1 minus y. All right, then ask yourself, what does y equal to? Well, y is equal to that, right? So now I have this minus sign, bracket, and then 1 plus 2e to the negative x. All right, and if I go ahead and simplify this by distributing the minus sign here, I will now get 1 minus 1 minus 2e to the negative x. And as you can see, the ones will just cancel off here, so I'm now left with just negative 2e to the negative x. And over here on the left-hand side, I can see that the left-hand side and the right-hand sides are equal, so that means that this answer does work for my problem. All right, so I won't be able to check my answer for all the homework questions, but you should understand what your solution means. If you have your equation as an answer, which is y equals to f of x, you should be able to plug that back into your original problem and make sure that the left-hand side equals to the right-hand side. Okay, let's move on to the next differential equation here. Okay, so I got y prime equals to 2xy plus 2x, and I also have this initial condition right here, f of 0 equals to 6. I usually just kind of translate this to a point right away. This is really 0, 6, so the equation or the solution will go through the point 0, 6. Okay, let's go ahead and take a look at the right-hand side of the problem here. So I have y prime equals 2. Now on the right-hand side of the problem, I can factor out a 2x to start. All right, so that's my greatest common factor. So let's factor out the 2x. If I do that, I get y plus 1. All right, so the goal is I need to isolate for y somehow. And for differential equations, you always want to have the y variables on one side and the x variables on the other side. Okay, so I'm going to just divide both sides by y plus 1. So I'm basically going to take this whole term here, y plus 1, and I'm going to move that downstairs. If I do that, I get y prime divided by y plus 1 equals to 2x. Okay, so that's a good first step, because now I can see that the y's are on one side and the x's are on the other side. Now on the left hand side here, I'm just going to rearrange this as 1 over y plus 1 times y prime equals to 2x. And one of the reasons why I'm just rewriting the problem like that is because I want to take the antiderivative, because I need to get rid of y prime. The only way to get rid of y prime is by taking the antiderivative of the left-hand side. And if you take the antiderivative of the left-hand side, you must take the antiderivative of the right-hand side. Okay. Now, if I take a look at this expression right here, what's the antiderivative of that? You can definitely use substitution, but just like the previous question, if you have 1 over something, the antiderivative of that is usually ln of the bottom. And I know that's going to be the antiderivative, because if I take the derivative of this, this will be 1 over y plus 1, and then the derivative of y is just 1 in this case. And that matches the original problem there. So I know the antiderivative is ln of y plus 1. So either you can do that by inspection, or you can definitely use substitution. But if you know that if you try ln of y plus 1, just take its derivative, and you'll notice that it does take you back to the original problem there. Okay, so that's the left-hand side. Now what about the right-hand side? Well, the antiderivative of 2x is going to be 2x to the power of 2 divided by 2 plus c. Okay, and then I guess I can just erase the 2's here. They just cancel off. And that is my antiderivative on the right-hand side. Now, we definitely need to find the value of c here using the initial condition, but the best way to find c is to isolate for y completely if you can, and we can do that by raising both sides to the power of e. So I need to get rid of this ln here, so the only way to get rid of ln is to raise it by the power of e, and if you raise one side by the power of e, you need to raise the other side by the power of e. These guys will kind of cancel each other off because they're inverses. So now you're left with just the absolute value of y plus 1 equals to e to the power of x squared plus c. Okay, so this step is very similar to one of the steps in the previous question where you need to go back to some grade 9 exponent rules where if I have a to the b times a to the c, this is really a to the power of b plus c. So as you can see, this part right here kind of looks like that part right there. So I need to split that part up into two separate bases here. Sorry, two bases where the bases are the same but the exponents are different. So if I do that correctly, that's going to be e to the power of x squared times e to the power of c. And on the left hand side, the absolute value, you can just get rid of that because it's going to be a positive expression here. So just leave, just remove the absolute value signs for this particular problem. And then our goal now is we need to recognize that this part here in green, that's just a constant, right? So e is a constant, so a constant to a constant to the power of a constant is just a constant. So I'll use the letter a to represent the constant there. And now I have y plus 1 on the left hand side. And just to kind of rearrange the terms, I will put the constant in front here, and this will be e to the x to the power 2. Okay, so that's looking pretty good now. Let's go back to the original problem now, and I know that the initial condition that's given to me is actually 0, 6, so I'm going to use this point now to find the value of a. Okay, so let's go back here, and I know that the initial condition is 0, 6. This is going to be your x value, and this is going to be your y value. So let's go ahead and plug this in. So 0 goes into there, and 6 goes into there. So this is 7 plus 1 equals to a e to the power of 0. And that means I just have an a here. E to the power of 0 is just 1, and 7 plus 1 is going to be 8. Okay, so, oh, sorry, I made a mistake there. I think I was just jumping too fast here, so that's actually 6. So 6 plus 1 is going to be 7, and that's going to equal to a. Okay, so a equals to 7. Once we have that, I guess we can go back and update our problem here. Let me go back to this purple box here, and let me just kind of erase all this. And let me just continue from this step right here. I have y plus 1 equals to, remember a was 7, so I can have a 7 here. And then e to the power of x squared. And just to kind of finish this off now, y would equal to 7 e to the x squared, and then I need a minus 1 there, and that should be my final answer for that particular problem. Okay, let's move on to the next question now. Okay, so for the next question, I have 2x times dy over dx minus 3y equals to 0, and I have this initial condition of y of 1 equals to 100. So if I translate this into a point, this is the point 1, 100. Okay, let's go ahead and do this, solve this problem here. I see a negative 3y there, so let me move that to the other side to get started here. Usually the first step, you just need to kind of move things around. And then after that, you can start looking for ways to get the variables on one side of the equation there. Okay, so I'm going to move the 3y over here. Okay, so I'll do this step by step. I need to make sure that the y's are all, the y's, which I'm highlighting in yellow, you want to make sure that they're on the same side of the equation. So I'm going to move the dx and the y. I'm going to interchange those two pieces. If I do that, I have dy over y equals to 3 times dx, and then I still have my 2x hanging on over here. Okay, so that's step number 1, just move things around. And after that, I can see that there's an x here, and I need to move this x to the right hand side, and I can do that by moving that right down there. So this is dy over y, and then the 2 still remains. This is going to be equals to 3 times dx, and that x finally moves downstairs like that. Okay, so there you go. I think if I take a look at this, all the y's are on one side and all the x's are on the other side. Okay, so let me go ahead and just maybe rewrite this in a way so that I can find the antiderivative. on my next step. So I have a 2 here, and I'll multiply that by 1 over y times dy. So I'm just kind of splitting that apart. And then on the right hand side, I have 3 times 1 over x times dx. Okay, so you don't have to split it up like that, but I just do that because it helps me with my next step. And I know for my next step I need to solve for y, and that means I need to get rid of the dy. In order for me to get rid of the dy, I need to integrate. So let me get on my orange marker here. I need to integrate one side. If I integrate one side, then I need to integrate the other side. And that will eliminate the dy and the dx once you find the antiderivative. Okay, so let's just clean up the left-hand side here. I have 2 times the integral of 1 over y dy equals to 3 times the integral of 1 over x times dx. All right, so just kind of cleaning that up, and I can see from this part right here, if I find the antiderivative of that, that's going to be ln of y. So ln absolute value of y, and then the 2 can just tag along. And on the right hand side, I have 3 times, and then the antiderivative of 1 over x is going to be ln absolute value of x, and then plus c. Okay. Then we need to continue solving for y, or isolating for y. So let's get rid of this 2 here. I can divide both sides of the equation by 2. So divide that by 2, divide that by 2, and divide that by 2. And then these guys cancel off. And now I have ln absolute value of y equals to, this part right here, the 3 and the 2, I can just leave that as a single coefficient as 3 divided by 2, and then times by ln absolute value of x plus c divided by 2. Okay, so once again, we're definitely cleaning up every single step here. And then after that, I need to get rid of this ln here. The only way to get rid of the ln is by raising the left-hand side by e, and that means you need to raise the right-hand side by e. Okay, so if I do that, these will kind of cancel off, giving you just the absolute value of y on the left-hand side, and this is going to be e to the power of 3 over 2 times ln absolute value of x plus c over 2. Okay, so we're almost there. If you want, you can get rid of the absolute values here because y is going to be a positive variable for all these differential equations. And let's go back to our exponent rules here. We need to remember that if I have a to the power of b times a to the power of c, that's the same thing as a to the power of b plus c. And as you can see, this part here in green kind of matches up with that part in green. So I want to make sure that I can split up the right-hand side into 2 bases with different powers. Okay, so that step's been kind of similar for the last few problems here. So let's go ahead and continue the steps here. That'll be e to the power of 3 over 2 ln absolute value of x, and then times e to the power of c over 2. And that's going to equal to y on the left-hand side. And now you just need to recognize that this part right here in yellow, it's a number to a number, right? A number to the power of a number, so that's simply going to be a constant. All right, so if I do that, this is going to be y equals to, let's skip a step here. I mean, the constant that we use is the letter a. A represents a constant, so I'll put that constant in front now. And then I have e to the power of 3 over 2 ln absolute value of x. Okay, once I have y equals to the expression on the right-hand side, my next step is let's go ahead and find the value of a, which is our constant, right? If I want to find the value of my constant, I need to go back to the original problem. And as you can see, I need to use this point right here, 1 comma 100, and then this is going to help me find the value of a. Okay, so here we go. I have the point 1 comma 100. Remember, this is x and that is y. So x is going to be 1, and I guess y is going to be 100. Okay, let's go ahead and continue solving the problem here. So I have 100 equals to a, which is, I think I used green here, so A. And then e to the power of 3 over 2 times ln of absolute value of 1. And remember, the ln of 1 is going to be 0. So if I have to continue here, 100 equals to a e to the power of 0. And e to the power of 0 is simply going to be 1. So this is now a equals to 100. So after all that work, we found out that a equals to 100, and now we need to go off and finish off our final answer here. So I think the best way to kind of finish off this question is go back to this step right here and just update that, because we know that a is equal to 100, so this will be 100 e to the power of 3 over 2 times absolute value of ln x. Okay. Although this is a correct answer, you can definitely simplify this a bit more. If you remember your exponent rules here, this 3 over 2 can actually go over here as a power, so that's going to be e to the power of ln absolute value x to the power of 3 over 2. And then I know that this e and that ln, they kind of just cancel off, and then you're left with 100. And this part right here, this absolute value of x to the power of 3 over 2, that just kind of comes down as one of the exponential e to the x ln x properties there, logarithmic properties. Okay, so that's your final answer there, 100 times the absolute value of x to the power of 3 over 2. Okay, let's move on to the next question here. I'm not sure if I need to repeat any key steps here. I guess maybe one thing I'll mention here is the absolute values on the y. I mean, eventually they kind of disappear because you know, y is on the bottom there, and we want to make sure that's defined. So it's going to be defined when y is positive. I guess the same thing with the absolute value of x. I guess you don't really need the absolute value of x's either, but I'm just going to include them in there just because so that it matches up with the answer key in the back of the book. Okay, let's move on to the very last question. The very last question in this homework video guide here. Okay, we have a problem that's written in a different format here. I have f of x equals to all that. And I know that f of 0 equals to e plus 1, and I need to go ahead and find the value of f of 2. Okay, so let's go ahead and translate this part first. I mean, this is still a coordinate. This is still 0, comma, e plus 1. And if I had to kind of translate this, that's going to be y equals to 2 times y prime. Actually, I won't use y prime. I'll use dy over dx. And then plus 1. Okay, so same kind of question. They kind of used a different notation here to represent the derivative, but I will just translate it back into the language or the notation that we're more familiar with. And let's go ahead and solve for this problem now. I guess step 1 for me would be I would circle this positive 1 and I would move that to the left hand side, and if I do that I get y minus 1 equals to 2 times dy over dx. And the goal is I want to make sure that the y variables are on the same side of the equation here. Okay, so maybe what I'll do first is I'll take this dx and move that to the left-hand side. And if I do that, I get bracket y minus 1 times dx. And that's going to equal to 2 times dy. After that, let me just highlight the y minus 1 here, and I guess I can move that to the right-hand side by dividing. So now I have dx equals to 2 times dy divided by y minus 1. And from there, right now it looks a little bit, it's not really organized, but the y's are definitely on the same side. So the y's are on the right hand side and the x's are on the left hand side. So all the variables are organized in a way where I can take the antiderivative. Okay, so let me just go ahead and rewrite this as dx equals 2. Now I'm going to split this up to be, so it looks like this, 2 times 1 over y minus 1 times dy. Now you don't have to write, the step like that, but this just kind of helps me in order to find the antiderivative here. And what I'm going to do now is I'm also just going to write this as, I'm going to move the dx over here. And I'm just going to erase this part right there. So now my equation looks like that. And the reason for that is it's just easier for me to write the antiderivative here. My goal is I want to solve for y, and I need to get rid of dy. And the only way to get rid of dy is by taking the antiderivative of the left-hand side, and that means you need to take the antiderivative of the right-hand side. All right, so if I clean this up, I have 2 times the integral of 1 over y minus 1 times dy equals 2 the integral. Now on the left hand side there's an imaginary 1 times dx. Okay, so now that we've kind of cleaned up both sides, now we can officially take the antiderivative. Now this part right here, this has come up a few times in this video guide. You don't have to spend time, you don't have to use the u substitution here to do this. I know that it's going to be ln because there's a 1 on the numerator, and I'm going to leave this as y minus 1 in the absolute value. And I know that once I take the antiderivative of this, the derivative of this, this is 1 over y minus 1 times 1, and that matches up with that. So I know my antiderivative of 1 over y minus 1 is indeed ln of absolute value of y minus 1. So you can do that by inspection, or you can use u substitution if you feel a bit more comfortable, but I won't be doing the u substitution steps in this video guide just to kind of speed things up. And over here on the right hand side, the antiderivative of 1 is going to be x plus c. Okay, and remember the goal is we still want to isolate for y, so let's divide both sides of the equation now by 2. So divide that by 2, divide that by 2, divide that by 2. After that, these guys cancel off, and I'm left with ln absolute value of y minus 1 equals 2 x over 2 plus c divided by 2. Okay, and the goal is we still want to isolate for y here, so I need to get rid of the ln here, so I need to erase both sides of the equation by e. So e on the left hand side and e on the right hand side. The e and the ln, they undo each other, so now we have just absolute value of y minus 1 equals 2 e to the power of x over 2 plus c over 2. Okay, and I think we've done this a few times already, so I'm going to write out the exponent rule one more time. As mentioned, that this is similar to that, so we need to split up the right hand side into 2 bases, just like that, and on the other side I will just leave y minus 1. The absolute values are kind of gone now. Okay, if I continue solving for y here, I guess that the plus 1 can go on the other side there, so I can just move this to the other side. Remember that this part right here in blue, that's just a constant, so I'm going to move that constant in front, so that's going to be a times e to the power of x over 2 plus 1. All right, so there's my equation so far, and now I just need to find the value of a. In order to find the value of a, we need to go back to the original part of the problem here, and our coordinate is 0, e plus 1. Okay, so let's go back down to the bottom now. Okay, so my coordinate here is 0, e plus 1. Okay, so remember this is our x value and that is my y value. Okay, so I'm just going to go ahead and just substitute y here. Y is going to be e plus 1 equals to a, and this e to the power of, well, I guess I have a 0 here, so this is 0 over 2, and there's a plus 1 over here. And I just need to isolate for a now. I see that the 1's actually just cancel off, and now I have e equals to a to the power of e equals to a times e to the power 0. And e to the power 0 is just 1. So now I have e equals to a. Okay, we're almost done now. Just a few extra steps to finish off the problem. I have a equals to e, and it's probably best to go over here now. If I update this formula here, it's going to be y equals to e times, I'll put this part in red now, this kind of looks weird here, e times e to the power of x over 2, and then plus 1. And after that, I just need to isolate. I need to just kind of figure this out, and we should be done here. So let me just erase all that too. Now, when I look at this e right here, there's actually an invisible power 1 there, right? So if I actually combine the exponents now, this is actually y equals to e to the power of 1 plus x over 2, and then I have the plus 1 over here. Okay, and now that I have my y equation all figured out, we need to go ahead and actually answer the final part of the question. The question isn't to find the equation solution, but if I go back to the beginning, I need to find f of 2 here, right? So the final part of this question is I need to find f of 2. So we have one more step to do, and then we're done. So just a reminder, I need to find f of 2. Okay, so what that really means is your x value is 2. So I'm going to take this 2 and plug that in over for the x. So final answer, y equals to e to the power of pink 1 plus, if I plug in that 2 there, that's the same thing as 2 divided by 2, and then a plus 1 at the very tail end here. And this is now going to be y equals to e to the power of, well, 1 plus 2 over 2 is just 2, right? 1 plus 1 is 2, and then this plus 1 at the very end. And that right there is your final answer, and that will conclude this video homework guide.